Hello everyone, and welcome to today's lesson on transformations of circular functions. This video is designed for IB analysis and approaches SL students covering topic 3.7, and IB applications and interpretation HL students covering topic 2.9. Let's dive into understanding how transformations affect sine and cosine functions. To understand and solve these questions, we should be familiar with the graphs of the sine and cosine functions. By the end of this video, you will learn how to transform sine and cosine functions. For that, I will break down the video into 4 parts. First, I will explain how to find the amplitude, which determines the vertical stretch or compression of the graph. Second, I will explain how to find b and discuss how it affects the period of the function. Third, I will cover how to find c and explain how it affects the horizontal shift or phase shift of the graph. Finally, I will explain how to find d and how it affects the vertical shift of the graph. The parameter a in the sine and cosine functions represents the amplitude. It affects the graph by determining the vertical stretch or compression. Specifically, a only changes the y values of the graph. As you know, the sine function's range is between -1 and 1. When we multiply the sine function by a, its range automatically changes. Specifically, the new range becomes between -a and a. Additionally, the amplitude is the distance from the midline of the graph to its peak or trough. If a is greater than 1, the graph stretches vertically. If a is between 0 and 1, the graph compresses vertically. Let's state the amplitude of the given functions and observe how it changes their range. As we know, the sine function ranges between -1 and 1. The amplitude of the function 3 sine x is obviously a 3, as multiplying the sine function by 3 stretches its range from -1, 1 to -3, 3. A sine or cosine function, the absolute value of the coefficient of the function determines the amplitude. Y equals to cosine x amplitude is 2. It stretches the range of the cosine function from -1, 1 to -2, 2. The coefficient of sine or cosine can be negative, but it does not affect the amplitude because amplitude measures distance, which is always positive. For example, y equals negative to sine x and its amplitude 2. We can also use negative for cosine x as an example. The amplitude is absolute value of -4, which equals to 4. To figure out the amplitude, we can use the graph as well. First, find the maximum and minimum values of the function. This enables us to calculate the distance between the maximum and minimum values. Then, just divide by 2 to get the amplitude of the function. Here it is 4. The amplitude might be different from the coefficient of the sine or cosine function. If the graph and the original function have the same trend, the amplitude, a, equals the coefficient of the sine or cosine function. Here a equals to amplitude because both functions are increasing from x equals 0. As you know, we first figure out the maximum and minimum values of the graph. This enables us to calculate the distance between the maximum and minimum values. Then, just divide by 2 to get the amplitude of the function. Here amplitude is 4. What is the coefficient of sine? A. If the graph and the original function have the same trend, the amplitude, a, equals the coefficient of the sine or cosine function. But in our question, there is an opposite trend. When the basic sine function increases, our example sine function decreases. So a equals the negative amplitude. It's -4. We can easily figure out the amplitude of a function by taking the absolute value of the coefficient of the sine or cosine function. To calculate amplitude from graph of a sine or cosine function, First, we need to locate the maximum and minimum points on the graph. Then, calculate half the difference between the maximum and minimum points. The formula for the amplitude is here. B is the horizontal stretch factor in the sine and cosine functions. It affects how the graph is compressed or stretched horizontally. It means B changes period of periodic functions. Do not forget the period of basic sine x and cosine x functions is 2 pi radians. Because the sine and cosine functions complete one full cycle or one full circle in 2 pi radians. Therefore, the period of both sine and cosine functions is 2 pi. When discussing time in hours in a day, such as on a clock, the period would be 24 hours. This is because it takes 24 hours for a clock to complete one full cycle or one full revolution. As you can see on the screen, we can easily determine the value of B using the formula. Now, you can easily estimate the period of the month function. It is 12 because in one cycle, there are 12 months. And we can easily calculate the B value again. To calculate the value of B, we can also use the graph of the function. Measure the length of one cycle. It is period of the function. If we know the period of the function, we can easily calculate the value of B. B times t equals to 2 pi. The rest of the calculation shows us that B equals 2. We can use the distance on the x-axis between the maximum and minimum points as well. But it is half circle, so we need to multiply by 2 to get period of the function. Again, the rest of the calculation shows us that B equals 2. In the context of sine and cosine functions, the parameter c represents the horizontal shift, also known as the phase shift. It just changes the XL values, shifting the graph horizontally without affecting the amplitude or period. As you see, the basic sine function graph starts from x equals 0. The example sine function graph starts from x equals to pi over 6. It means c value is pi over 6. Let's solve another example. First, figure where x makes y equals to 0. It is x equals to negative pi over 6. Then substitute negative pi over 6 for c. Be careful, follow the original formula step by step. To calculate the horizontal shift, we can use the function equation. Simply put, c represents a horizontal shift. We can also use the graph to figure out the horizontal shift. For a sine function, when y equals d, which is the midline value, the corresponding XL value represents the horizontal shift. For a cosine function, when y equals to maximum value of the function, the corresponding XL value represents the horizontal shift. I'll provide 2 examples to clarify the graph portion. Now, we should focus entirely on where the sine function intersects the midline. In the example, the midline is y equals 3, and the first intersection point has an XL value of pi over 4. This represents the horizontal shift denoted as c. Let's go through one more example to clarify the horizontal shift of a cosine function. From the basic cosine function, we observe that the initial point occurs of cosine function at x equals 0, when y equals the maximum value. In this example, the cosine function reaches its maximum value at equals to pi over 4. It means that the LCL value, representing the horizontal shift, is also pi over 4. The parameter, dl in the sine and cosine functions represents the vertical shift or the midline of the graph. The parameter dl in sine and cosine functions simply changes the vertical position of the graph without altering its shape. It means that only the y values of the graph can be changed, not the x values. Let me show you the effect of the d value on the range visually. The basic sine function has a range between -1 and 1, so we can observe how the range is changing. It is increased by 3 because d equals 3. Now, if we can figure out the maximum and minimum values from the graph or another method, we need to use just the formula to determine the d value. Maximum value is 6, and minimum value is -2. From formula we will get d equals to 2. To calculate the vertical shift, we can use the function equation. Simply put, d represents a vertical shift. D is known as midline as well. First, we need to locate the maximum and minimum points on the graph. Then, calculate half the sum of the maximum and minimum points. The formula for vertical shift or d is here. Basically, for transforming sine or cosine functions, we need to know how to calculate a. for vertical stretch or compression, b. for horizontal stretch or compression, c. for horizontal shift, and d. for vertical shift. That's the end of our video lesson. I recommend you solve related questions to understand the topic more deeply. Thanks for watching the video.